Welcome to another tutorial on Matlab. In this tutorial series, we are looking into the concept related to the basics of Matlab and how we can create basic Matlab scripts. In this particular tutorial, we will be having a look into the three-dimensional plot that we have available for Matlab environment. So let's get started. So if you see a three-dimensional plotting, then in this case you will have two types of plot. One is a 3D line plot, and another is a 3D surface plot. So in a three-dimensional line plot, you will have a command called plot3, and this is basically similar to a line plot in a two-dimensional plane, but it will have some additional axes. So usually in 3D plotting, you will have three axes. One is X, another is Y, and another is Z. And based on the individual points that you are getting, like suppose this is the point in which you are having this vector. So you will have it like this. So suppose this is your point which has maybe one in the Z direction, one in the X direction, and one in the Y direction. Then the vector will be, so the vector equal to 1 comma 1 comma 1, and this is the point at which it is intersecting. So by connecting points like this over the three-dimensional plane, you will get a line maybe like this, and this is basically called a line plot in a three-dimensional plane. Okay, and that is how you can interpret a plot3 command or plot3 command execution. So basically in a three-dimensional plane, it will just connect the dots and will create the lines. So this is about the line plot in a three-dimensional plane. So let's have a look into the same with the help of some example in the Matlab environment. So here we have a script which has all the plot commands. So first I will do clear all and close all the existing plots. Along with that, I will also clear the screen. So just hit Control Enter. So it will clear the command window and as well as the workspace. Now we need to create some data which we want to plot. So the first one is X. So this is the X-axis data that I created. So in this case, what I am basically doing, I am creating a array or a vector through which I will be able to create some data set for the X direction. So if I right click, evaluate, then I will be having a vector of length this one, and that I will be running over my evaluations. Next is I am taking sign of X. So all points of X, I am executing the sign value for that. And then for this Z, I'm using the cos value. So I'm evaluating that. So here I got all the three axis points, and I got three values. And based on this, now what we can do, we can start a 3D plotting. So first what we will do, we will create a figure in which we will be doing this 3D plotting. So right click, evaluate. So I got this window. Now I'll put it on the right hand side, and let's keep this window on the left hand side so that we can see both execution and outcome parallelly. Okay, so now we have this plot3 command where we are passing the variables x, y, and z, and I'm also using a line width command or line width option, through which I'm just increasing the width of the line so that it will be visible on this three-dimensional plane. Along with that, there is some title and all those things we will see. Let's start the debugging part. So I'll just put a debugger and run this program. Okay, I got this plot. I will just keep it on the right hand side. And now let's step into the program. So first is plot3. So plot3 got generated. So here you can see we got this plot, and now if I step again, then it will give the title. So the title which we seen in the last video, and X label. So you are getting X label also over here, angles in radian, and then Y label. So sine function in the Y label, and Z label is the cos function. Okay, so in the Z axis we do have the values for the cos, and in the Y axis we do have the value for the sine. Now grid on. So I turned on all the grids in a 3D plane, and grid minor. So I turned on the minor grid also. Now I want to view it at a particular angle. So I just hit enter. So the view angle changed, and that is how I do create this three-dimensional graph. And here you have a tool which is basically a viewing angle tool. So you can rotate and see the correlation between the cos and the sine. So suppose if you want to see it on the function side, only functions side, right? So for that you need to omit the other x-axis part. So if you plot it, as we already know, this forms a circle. So this is the circle that it represents. So if you just want to see only the sine function, or only the cos function, then you can see it like this. Okay, so you will be only seeing the cos and the angle. So based on this, the cos is behaving like this. If you want to see it on a sine perspective, right, then you need to make it like this, and you will get a sine wave. Right? This is a sine wave which you are getting, angle and the radian. So you can see the sine function over here. So that is how you can examine and correlate the three-dimensional form of any output, so that you will be able to analyze the graphs in a proper way, and also maybe can find out some hidden relationship between the functions that you have. So this is about the plot3 command and the relevant commands through which we do create this particular graph. So this is in the figure 1, which we can see over here. Okay, so so this is about the line plot in a three-dimensional plane, and let's jump into the other plot, which is the surface plot. So in case of Matlab, we do have multiple types of surface plot. First is the So in case of a surface plot, we do have multiple options for creating a surface plot. First is the mesh command. So This will create a mess inside your graph, and those mess will be like a um, uh, like creating a frame and in which the plots will be done. We will see it in detail in the MATLAB environment. And next is we have surf command. So this will create surface, and we also have multiple options along with this. So we can smooth the surface, or we can have a rough surface, some smooth or rough, where we have some outlines with this will be with outline. And then we also have contour plot. So we do have contour plot, and we also have surface C, surf C. Okay. And we do also have some supporting functions, so through which we will be creating all these plots. So let's have a look into the concept related to the same, like how the surface plot looks like and how it works. So suppose this is your three-dimensional plane, and here you have one point here, and suppose another point here and another point here. So these points are evaluated based on the points that is created here, right? And if you just connect these points, then you are basically creating a surface. This is basically called a blank, and this will be a surface. And by connecting such surfaces, like suppose I have one more point over here, so this will connect here, and basically you will be creating surfaces, and through that you are basically, suppose there is one more point here, then you are basically connecting and creating this surface. So basically when you jump into a surface plot, it is a actual surface that is visible on all the viewing angles, and you can feel it in the MATLAB environment. But for this, basically you need to create a mesh grid surface. So mesh grid is like, suppose you have 0 to 5 over here, the values for the x-axis, and suppose same 0 to 5 here for the y-axis. So this will be your y-axis and this will be your x-axis. So based on multiple combinations of these, so there will be a mesh that will be created on the base like this. This will be the values of y, and those values of y will intersect with the values of x. So suppose x is in the red color, so these will be the combinations. So this we need to create with the help of a mass grid command. So suppose for example, what is this point? This will be 1 comma 1. Suppose this is 1 and this is also 1, then you will have this point as 1 comma 1, right? Next point, this one, this will be supposed 2, and this is already 1, so you are getting 1 comma 2. So like this, all the combinations are getting generated with the help of this mesh grid command, and you are basically creating this surface, and on top of that you are just plotting this using the function. So in this case, what you need, three major variables you need. So it is not like exactly with the plot 3. So the first variable is your x vector, which is this one, and next is your y, so that you need. And with this, you need to create the mesh grid. So with the help of this mesh grid command, you need to create this entire base surface, which will be like capital X and capital Y, and these will be vector combinations. It will be like, suppose these are two variables, so every variable in this X and Y will have a combination of two elements. So suppose A and B. So using this, the coordinates are being defined, and based on this, what basically is happening in the third step, you need one more variable, which is Z. This will be a function of this uh, vector which you have. So suppose in our case, we are getting sine of capital X and plus sine cos of capital Y. So suppose this we want to evaluate. So in this case, this is the Z that we are getting, the surface part. So that will also have points, 2 points, and that will create a surface on the top level. So using that function only. So this is the basic concept behind how we should create a surf plot. But let's see how it looks in MATLAB using multiple options that we have. So now we are in the MATLAB environment. I will just remove the debugger, and let's have the data which we already have, which is this one. So first what I will do, I will just clear everything and close everything. Then I will just create the data. So the data I do have. Now, in this case, we will be doing this surface plot. So you need to create a mesh grid by using the variable X. So I use 2 times X because I want a square surface, base surface. So if I right click and evaluate this, I will get this mesh grid. So let's see like how the combination of capital X and capital Y looks like. So if you double click over here, you can see combinations, right? If you see X parallelly, then you can see point X has 0, 0.1, 0.2. So if you see capital X, then you can see 0, 0.1, 0.2, and everything will be same in this entire column. Okay, because it is in the direction of X. Okay, and if you see Y, then it will be like this. And if you see capital Y, yeah, so this is the capital Y, and you are getting the combinations in this way in the um, column wise format, right? So this creates the combinations. So if you see X and Y, so in vertical direction, X is same, all values are same, but in the vertical direction for the Y, all these values are changing, but in this direction, it is all same. This is basically representing the X direction, and this is basically representing the Y direction, and they are making the points coincide to create the surface. Now, let's go to the script that we have. And here we will create the Z, capital Z, which is a combination of this X and Y. Okay, so we got Z, and Z also has the same size, I think almost same size. Yeah, so Y is this size and Z is this size, and X is this side. All are having same size, so that we can plot it properly. So I'll close all the open variables. Now, what we need to do, start plotting. So first we will do the first plot which we do have. So for the surface, so I will right click, evaluate. Okay, this is the mesh. So first we will evaluate the mesh plot and see like how this looks like. I will keep this on the right hand side so that we can view it properly. Now I will evaluate this mesh command, which is using the data which we created here, and just right click evaluate. So you can see it is a wireframe. If we zoom in, then you can see the wireframes. You can see the wireframes. It is not filled with any color, but it is white, and the wires are connected over here. So that is how this graph looks like for the mesh command. And when you do use this surf command, then it will fill all these gaps which is of white color. Now we will do some customization like title, and we'll evaluate title. So you got the title. Along with that, we need to have the labels. So labels I am keeping. So all the labels are there, sign, cos, and all those things. And then we need to turn on the grid and the grid miner. So we will turn on grid and grid miner. And along with that, we also want a viewing angle. So as it is a 3D plotting, right? So we need to have a proper viewing angle. So I just got this viewing angle. So this how you will do implement. So you can see this tool that is on top. Just click on this tool and try to see like where you can have it in a proper way, and like whichever the way that you want to view it. And there on the downside, right, you are able to see AZ azimuthal, which is basically 61, and elevation, which is basically 38. If you want a particular view, azimuthal and elevation, then you can read that by having it in a defined way, and then you can use those two numbers so that it will adjust the view in your own way. So if I just right click, the view will get changed. So if I just right click, then my view will change now. See? Yeah. So this is basically a mesh plot. Till now we have seen this mesh plot, and now we will be having a look into the third figure, which is basically a surf plot. And we'll see like how this appears. So first we will create that figure. So this is the figure window. So I'll keep it on the right hand side. Now we will be doing the plotting for the surface. So this is the surface. So you can see the difference between mesh and the surface. If I keep on the left hand side, so you can see the difference. There is this color got filled up in this case. So if I zoom in, so this is the case for the surface. And if I zoom in here, you can see it is not filled with any color. This is filled with the colors. But so you can see the structure, it is almost similar, only the colors are not filled. Okay, now so let's analyze this one. So now what we need in this case, so we need some additional color bars which will just tell us like which color is representing which quantity. So for that we need this color bar command. So if we just evaluate this, then you will get a color bar on the right hand side which represents the defined values for this particular color map. And along with that, we do have also the axes and titles. So I'll just evaluate that, and you'll get this full graph, and also the grid miner and grid on for the grids to be on. And now suppose I want to change the viewing angle, then I can change that. Yeah. So this is my viewing angle, which I already set. So this is about the SERP plot. Now, suppose in the same subplot, you want to do some, like you can see there is wires that is distributed in this particular wireframes that are distributed in this particular um, graph, right? So you can see the wireframes. Suppose if you want to make this graph smoother without having this wireframe, then in that case you can do that as well. So let's do it in a next figure. So let's create one more figure, and in this figure we will be doing this. So surf again. So we got the surface plot. Then suppose I'm using this shading. So there are multiple type of shading that you can see in the documentation. So you just need to type doc and shading. If you evaluate this, then you are getting a smoother graph. Why you are getting this smoother graph? Because that wireframe got removed here. And you can also then use the color bar to see this. So this is how you can get a smooth graph, and I will just evaluate the remaining commands to get the proper view and the titles. So this is how you can do plot a 3D surface plot without the wireframe. Okay, this is how it looks like on multiple angles. Okay, then we will have one more surface plot, which is basically flat shading. So let's apply some flat shading now. So that we will do with the help of another figure. So let's create another figure. So what is basically flat shading? So first let's evaluate the surf, and then we use that flat shading. So shading basically how it is feeling it. So it is almost the same as the interrupt shading, but if you have less points, less data, then it will be more visible, the difference. And let's put the color bar and the remaining part as well. Lay down the minor and the title and access. So this is done. So sometimes in the surface plot, you do want to change the color schemes. Like the color schemes, the default one maybe will not be suitable for your application. So in that case, you can also change the color maps. So let's see like how color maps can be changed. So this we will implement in the next figure. So let's evaluate, create the next figure, which is this one, and we keep it on the right hand side. Then we do evaluate and create this subplot, and then we use that flat shading. And then in the shading, suppose now I want to change the color map. So I want to use winter color map. So this is how the color map now got changed. And for that also you can update the color bar. So based on that same color map, the color bar will also get updated. And then this basic commands which we have for the plot. Okay, so this is how you can change the color maps. There are multiple color maps that you will be able to see in the documentation. So based on that, you can use that type of color map in your implementation. Okay, so this is about only SERP and its variants. But next, we do have one more variant for the SERP, which is basically SERP C. So let's implement this in a different figure. So let's have it as a um, figure 7 and open it. Right click, evaluate. We got this figure now. And let's create the SERP plot. Surf C plot. So it will take the same data, but it will be command as surf C. So if you evaluate this, then you will get both contour plots, which is you can see on the base, and you also will be able to see the surface plot with the mesh on, or with the wireframes on. So you can see the contour plot is downside. This is the contour plot, and this shows like how the values are changing on a two-dimensional plane. Okay, so this is done, and also we can do this. So just right click, evaluate. Okay, this is the default view. Then let's jump onto the contour plot. So how you can map something three-dimensional into a two-dimensional plane. So for this, let's do the figure creation. So it will be figure 8. Right click, evaluate. So we are getting the new figure now. And yeah, so let's start with the contour form. Here you can see the contour. It is with the filled colors that you are able to see on the base. And if you want to view it, you can also view it on multiple angles. As it is a three-dimensional plane, you can see it, but as the contour plot itself is a two-dimensional plotting, so it will be just like a plane on a three-dimensional view. So you can see it is better to have it on a two-dimensional plane. And if you just set all these commands, then you can see it viewing angle, so that you will get a proper feel of this contour command or contour plot. Now let's combine both of them and see like how the graph looks like. So this will be the ninth plot that we will be having. So let's right click, evaluate. So next plot. Okay. Now what we will be doing, we will be doing two types of three-dimensional plotting in same figure. So first we will do the surf plot. So same what we had. Then we will be doing a hold down, and then we will be doing this contour F. So this is how you will be able to get the view for this. In case of your application, you want both the plots, then you can do it like this, two plots on one figure window. So you can see the contour plot over here as well, and you can also see the surf plot here as well. Okay. So you can see the yellowish part is the topmost part, which you are able to see on the sub. So from this contour plot, you will be able to get a two-dimensional feel, and from the subplot, you will be able to get a three-dimensional feel. This is all different types of plots that you are able to see in this particular tutorial. The first one is the surface plot. The second one is the contour plot, and we did also color mappings and all those things. And we also smoothen out the surface plot, and we also did some color grading change, and we also did some mesh plot along with that. And we did also analyze like how the multiple plotting techniques looks like in a 3D plane. We did also cover how these basic concept behind the surface plotting is there in the MATLAB environment. So this is all about 3D plotting. I hope it will be more helpful while doing the implementation. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Take care.